Hello guys, I'm Professor José Bezerra de Menezes Filho. I live in Brazil, in the state of Paraíba. In this map, we can see my state, the state that I live. This is the picture of mine, and I hope you enjoy this video. Well, in this lecture, I want to show you the two essays of the transformer, the short circuit essay and the open circuit essay. Well, this is the model of transformer, the well-known model of transformer. Here is the resistor of the primary coil and the resistor of the secondary coil, the coil of the secondary side of the transformer translated to the primary side. This is the reactance of the primary, and this is the reactance of the secondary, reflected to the side of primary of transformer. And this is the representative circuit of the iron. We can see the resistor referring the loss of Foucault corrente, eddy current, and the hysteresis, and this is the reactance. And so this is the load of the transformer. And let's start with the short circuit essay. We must provide a short circuit in secondary winding and monitoring the current in order not to surpass the nominal current of the transformer. So we put the ammeter in order to measure the current in the secondary side of the transformer, and we put the wattmeter in order to measure the power supplied to the transformer. And here you can see ammeter and the voltmeter. And here this equation shows that it is possible to bring together the reactance of the primary and the reactance of the secondary reflected to the primary, and we put it together to form the equivalent reactance of the transformer. In the same way, we can get the equivalent resistor, that is the sum of the resistor of primary and the plus resistor of secondary reflected by the primary. PCA is the power measured by the wattmeter. It's equal to equivalent resistor multiplied by square IP. IP is the current of the primary, as we can see here. So it is very important to manipulate the value of the voltage source in order to maintain the current in the rated nominal value of the transformer. In this case, as this voltage is about a 10% of the rated voltage of the transformer. So the voltage of this branch is very slow, and so it is possible to eliminate this branch in order to simplify our circuit. As we can see here, we can see that we can eliminate this branch of circuit because the voltage is too low compared by the rated voltage of the transformer. And we can see here that the equivalent resistor is the sum of the two resistors, and the equivalent reactance is the sum of the two reactance. I2, this I2, this current is this current reflected by the primary, and the equivalent impedance Z aqui, equivalent impedance, it's equal to voltage 1 obtained by this measure divided by I21 that is obtained by the ammeter. We know that the equivalent impedance, square equivalent impedance, it's equal to sum of the square equivalent resistor plus square equivalent reactance. So we can get the value of the equivalent reactance as can be seen here. Equivalent reactance, it's equal to square root of square equivalent impedance minus square equivalent resistor. And how can we obtain the equivalent resistor? It's simple. Equivalent resistor, it's the value measured by wattmeter divided by square IP. So we can put this value here. Let's go. We can put the value here. Let's. Okay. And the equivalent impedance, it's obtained by this expression. So this is the short circuit assay. In the open circuit open circuit SA. In this case, we must let the secondary without any charge. It's open, as we can see here. The voltage we can put here is the rated voltage of the transformer. And in the same way as the former SA, we must put the wattmeter, the ammeter, and voltmeter. And as we can see, the rated voltage is applied to this circuit. The secondary current is 0. So the secondary current reflected by the primary, this expression, it's equal to 0. And the voltage drop in this impedance is very low, and it's possible to annulate the influence of this impedance in this circuit. So we can view this circuit with only this branch, okay? And let's to analyze the power supplied with the voltage. In the former circuit, we analyzed it with current, and in this circuit, we can analyze with voltage. So the equivalent impedance of this branch is equal to this expression. The apparent power supplied to the transformer squared by apparent power, it's equal to square power active power plus squared by reactive power. So we can put the V1 multiplied by I1 as it's equal to S squared of this expression. It's equal to square of PCA plus square of key. What is it? It's a reactive power, and given by this expression, the square of the voltage divided by reactance, magnetizing reactance. So we can calculate this expression, square V1 divided by a reactance of magnetizing reactance, it's equal to square root by this expression minus PCA square PCA, as can we can see. So Xn it's equal to square voltage of the primary divided by square root of the apparent power, square of apparent power minus square of active power. So Xm it's equal to square of voltage of primary divided by who is PCA. PCA it's this expression. So we can put this expression here in this place and we obtain this expression. So if we divided the numerator and the denominator by square v1, we obtain finally this expression. And so, as we can see, equivalent impedance it's voltage of primary divided by current of primary. So the inverse of this expression is this expression. We can put in this expression here. So we can obtain this expression. And all is simplified. We put the voltage, the rated voltage, measure the power, measure the current, measure the voltage, and divided the voltage by current, obtain equivalent impedance, put here, and we can get the resistor as RC divided square of voltage by PCA put here. So we can get Xn. Okay guys, thank you, and I hope this video help in the some way. Okay.